statistical test used to determine whether cat IQ differs by coat color and breed is the Way ANOVA, or Analysis of Variance procedure. We recently assessed the intelligence of over 5,000 cats with our Maine Cat Lab intelligence test. Cat owners enrolled their cats and answered 10 7-point questions on memory, intelligence, attention, associative learning, and adeptness. When we grouped them all by their color and ran statistical tests on each coat color's overall average IQ, the means, and how much variance existed within each group, we found some statistically significant differences. The robust Way ANOVA revealed that ragdolls were at the bottom, and tuxedo-colored cats and Maine Coon and Bengal breeds were at the top. The majority of the cats in our study were mixed breeds, which makes up the vast majority, about 95% of domestic cats. They're typically categorized by their owners by color: tabby, orange, tuxedo, which were the categories that we used in our study as well. The Way ANOVA is used by natural and social scientists for many tasks. When researchers seek to compare mean differences on a scale or numeric variable, such as intelligence score, between categories such as cat color, orange, tabby, gray, etc., it's the tool of choice. If you take any medicine, the efficacy of your drug was probably assessed via an ANOVA. A common medical application of a Way ANOVA would be in a drug trial, such as if we were examining the use of drug A, B, or C on 3 different groups of men's blood pressure. In that example, the drug assigned would be the category, and the resulting change in blood pressure would be the numeric dependent variable. So a Way ANOVA may be used whenever we're seeking to examine whether categories of people, cats, or an intervention such as a drug seemingly produce a different effect on a variable that's measured on a numeric scale, such as anxiety score, intelligence score, or blood pressure. But back to cats. Before conducting the statistical test, we need to set up our data in a spreadsheet as follows. With the help of their owner, we assigned each case or cat a precise cat color, his or her name, and their unique IQ score. All of the cats were then entered into a huge data sheet in the statistical program SPSS, which we purchased with our own funds. No taxpayer dollars were used in this task. We also discussed and designed the study in our spare time. Our day jobs of teaching human undergraduates and conducting human personality and cognition research at the University of Maine at Farmington. Though many humans at our workplace have become interested in our results, and I hope videos like this help students see how helpful statistics can be in pressing questions like cat intelligence testing. So the steps to conducting an ANOVA, a Way ANOVA, are as follows. Before collecting the data, we define our hypothesis and our null hypothesis. The null hypothesis was that cat IQ scores do not significantly differ as a function of color. The alternative hypothesis, the one that Bryce and I had faith in, that we suspected might be true after hearing from hundreds of cat owners, is that cats do indeed differ in IQ by color. The caveat is that there are always exceptions to the rule, such as the super bright ragdoll in our study who runs the neighborhood, according to her owner. Next, we set alpha or significant level. The standard is typically 0.05, and that's the probability level that we used in our Way ANOVA. Next, with the use of SPSS, in which we have transferred all of the cats' data, 5,000 cats at this writing, we run a Way ANOVA with cat color as our independent variable and intelligence score as the dependent variable. Next, we execute that ANOVA, which calculates the mean intelligence scores for each group: orange cats, tabby cats, gray cats, calicos, etc., and then indicates whether somewhere in those group means, whether there and the variability across all cats in that group differ significantly. The ANOVA takes into account both of those things, the average or mean score for each cat color, as well as the variability across that cat color, and whether that mean is significantly different than the overall mean of all cats and the variability of all cats. So we're almost done. The next to last step reveals the F statistic, which is calculated by variance between the groups divided by variance within the groups. So that F statistic, if the variance between the groups is large and variance within the groups is small, that results in a large F statistic, meaning that between group differences are there. They're large. They're statistically significant. But not all cats cat groups may significantly differ from each other, such as tuxedos, who are just a tad higher on average than black cats, a non-significant difference between that pair, but tuxies were much higher than oranges. So to determine those between group significance levels on all of those different pairs, we needed to conduct one more procedure, a post hoc analysis, to see which groups differ significantly from each other and which groups were so close in difference that it was not statistically significant. So if you look at our final summary of average IQs by color, we may see that Bengal cats, which are a breed, not just a color, are very high, but Maine Coons are also high. Do they differ significantly from each other when they're so close? After a post hoc test between that pair, we see that they don't. They are also, they're statistically almost alike. But we do see that ragdolls and tuxedos do significantly differ from each other in the post hoc test of that pair. So post hoc tests are conducted on all of the different combinations, tuxedos to oranges, tuxedos to ragdolls, ragdolls to oranges. There are too many one-on-one tests to report here, but we will report on all the significant post hoc test results if you want to scrutinize the nitty-gritty details in this metric. We can now claim, assuming our IQ test is valid, that cats do, at least in our sample, differ in intelligence by cat color. Because our sample is so large and comes from across the world, we're feeling pretty bullish about these findings. Though we must add, and our followers let this know too, there are always exceptions to these general widespread findings. The super duper smart orange cat, the dullish Maine Coon do exist, as well as the ragdoll who rules the neighborhood. And importantly, there seems to be no difference in affection, in attachment, in love as a function to how bright or dull a cat is. So that's it. Stats and cats. Until next time, stay kind and thank you for liking and sharing our work. We greatly appreciate the outpouring of support for the Maine Cat Lab, your stories of your bright and not so bright cats. We thank the press for having interest in our research, and we will be in touch soon with another video on cat science. Until then, take care.